Mary, as you all might have known, the coal power plant is used to generate electricity in northwest Alaska. The coals are combusted to produce electricity. Recently, the DOE of Northern Alaska had discovered that the coal power plant had been responsible for the acid rain going on in the area for the past few weeks. Hence, the plant must be shut down for investigation. I've assigned a group of investigators to assist me in conducting a proper data analysis on 2 different batches of coal used in this plant. Based on the data, identify the coals that can be used in the plant that will meet the requirements for the discharge.
Hi Mary.
Hi.
This is our proposed solution for your problem. Now let me present it to you.
Acid rain is a type of environmental pollution caused by the release of harmful gases into the atmosphere, primarily sulfur dioxide and nitrogen oxide. And these gases are being emitted by human activities such as burning of fossil fuels, industrial process, and vehicle emissions. When sulfur dioxide and nitrogen oxides are released into the air, they react with water, oxygen, and other chemicals to form nitric acid and sulfuric acid. These acids then mix with the rain, snow, fog, or other forms of precipitation and fall back to the Earth's surface. This process is known as acid rain.
Okay, the negative effects of acid rain are environmental damage. This is when acid rain can cause significant harm to ecosystems including forests, lakes, rivers, and soil. It damages or kills trees and plants, disrupts aquatic life, and degrades the habitats of various organisms. Water pollution is also caused by acid rain. Acid rain increases the acidity of lakes, rivers, and streams, making the water unsuitable for certain aquatic species. It can also mobilize toxic substances such as aluminum from the soil into water bodies, further endangering aquatic life. And for building and infrastructure, the acid rain can corrode and erode buildings, monuments, bridges, and other infrastructures made of stone or concrete.
Okay, so first of all, my name is Aida. So the general solution for the acid rain problem is that the coal power plant need to use coal that has sulfur concentration less than 6.2% weight. This can reduce the amount of sulfur dioxide released from coal burning power plants in the air. Thus, less acidic gases will react with water when it is raining. The problem involved is that the Department of Environment (DOE) had discovered the acid rain phenomenon in the coal power plant in northwest Alaska area, and the power plant need to be closed for investigation. So our group has been assigned to do a proper analysis to determine the cause of acid rain in the area and to identify the suitable batch of coal that meet the specification.
Proposed solution by Aishah Azlinie. Acid rain is produced from coal with high sulfur contents. We can find which coal has higher sulfur content by calculating the empirical formula of the coal with the mass given. The burning of coal with high sulfur content is the main source of sulfur dioxide emission that leads to acid rain. When the high sulfur coal is burned, the sulfur content in the coal is released into the atmosphere as sulfur dioxide. Once in the atmosphere, sulfur dioxide reacts with other chemicals to form sulfuric acid, which then falls to the earth in the form of acid rain. Therefore, the use of low sulfur coal or alternative energy source can reduce the amount of sulfur dioxide emission and help prevent acid rain.
This is the data table for coal A, and to get the percentage of sulfur, we need to divide the mass of sulfur dioxide with the molar mass of sulfur dioxide to get the mole. Then the mole of sulfur dioxide is times by the molar mass of sulfur to get the mass of sulfur. Mass of sulfur is then divided by the total mass of products times by 100 to get the percentage mass of sulfur. This calculation will help you to find the percentage of mass for nitrogen, hydrogen, and carbon. And in order to get the mass percentage of oxygen, 100% minus mass percentage of carbon, hydrogen, nitrogen, and sulfur will get you the mass percentage of oxygen. So for coal A, our mass percentage for sulfur is 4.46. For coal F, our mass percentage for sulfur is 6.62.
Next, after getting the mass percentage of each atom, we need to find the empirical formula for each coal. First, we need to assume that 1% is equal to 1 gram. As example, 66.01 gram, 66.01% is equal to 66.01 gram. And then, we need to divide the mass of each atom by its molar mass to get the mole. Then, we need to divide the mole of each atom by the smallest mole, which to get the ratio for each atom. And then we round off to the nearest whole number to get the prefix number of each atom in the element of coal, for coal A and coal F. After comparing the mass percentage of sulfur in coal A and coal F, we can conclude that coal A is more suitable for the batch of coal that meet the specification where the concentration of sulfur is less than 6.2% by weight, and it can reduce the acid rain compared to coal F.
Based on this investigation, the objective is successfully achieved, which is to determine the cause of acid rain in the area and to identify the suitable batch of coal that meet the specification. In short, acid rain brings negative impacts such as environmental damage, water pollution, and building and infrastructure damage due to the emission of sulfur dioxide during the burning of coal. Based on the calculation, we get that coal A have 4.46% of sulfur by weight and coal F have 6.62% of sulfur by weight, which have meet the specification that lead to acid rain. Hence, the suitable coal used for a power plant is coal A, which must not more than 6.2% of sulfur component in order to reduce sulfur dioxide release during the coal combustion. That's all.